In this video, we're going to learn to draw another type of diagram known as an energy profile diagram. Earlier, we learned to draw an energy level diagram. As mentioned, energy level diagram only has a y-axis. The y-axis is energy. And then in the diagram, we show the energy levels of your reactants and your products. Okay, and the energy change involved, the energy change between your reactants and products is known as your enthalpy change. Now we're going to learn to draw another type of diagram. It's called energy profile diagram. Now energy profile diagram has a y-axis and has an x-axis. The y-axis again is energy, and the x-axis is your progress of reaction. Meaning, as we change from reactants to products, how would the energy change in between reactants and products? So earlier we were only concerned about the initial and final energy levels of your reactants and your products. So we were only concerned about before and after. Now we are concerned with what happens in between. How would your energy change as your reactants react, as your reactants interact and become products. Now, to know how energy changes in between reactants and products, we need to make reference to one of my childhood favorite toys, which is Lego. And what's so fun about Lego is that one box of bricks can allow you to make multiple models. However, if I want to change from one model to another model, what is the first thing that I need to do? The first thing that I need to do is I need to dismantle the existing model. Okay, so why is that important is that when reactants undergo reaction to become products, before the reactants can form your products, they need to be dismantled, meaning the bonds in your reactants must break. Okay, and if you can recall from our very first lesson, we learned that bond breaking requires energy. Bond breaking is endothermic. So with that in mind, let's try to construct the energy profile diagram. In the energy profile diagram, once again, we have the reactants and the products. Your reactants would be hydrogen and oxygen. Your product would be water. Now, as mentioned before, hydrogen and oxygen can become water. We must first break the bonds in your reactants, and bond breaking is exothermic. So there will in the middle, somewhere in the middle, you would expect the energy to increase. Now, after the bonds are broken, they will form new bonds to become the product, and bond forming is exothermic, so you expect the energy to decrease. So this is how an energy profile diagram looks like. Okay, a few things to take note in an energy profile diagram. So once again, the energy level between your reactants and products is known as delta H, or your enthalpy change. This is something new. The energy level between your reactants and the highest energy level is known as your activation energy. Okay, and it's given the symbol EA. So what does activation energy represent? It represents the minimum energy that your reactants must have before a reaction can occur. So what happens if your reactants do not have that amount of energy? Alright, so when they collide, they don't actually undergo any reaction. Okay, so once again, activation energy is the energy between the level of your reactants to the highest energy level in the diagram. So as mentioned, activation energy is the minimum amount of energy that your reactant particles must have in order for a reaction to occur. Otherwise, when they collide, no reaction can occur. So we have seen the energy profile diagram for the reaction of hydrogen and oxygen to form water. Now let's try to construct the energy profile diagram for the opposite reaction. For the opposite reaction where we convert water into hydrogen and oxygen gas. Okay, so now the reactants will be your water, and water is at this particular energy level, and then your products would be your hydrogen and oxygen, which is at this particular energy level. Now by putting the forward and the reverse reaction side by side, I hope now you can see very clearly that when you flip a reaction, the magnitude or the amount of delta H, the value of delta H doesn't change. The only thing that changes is the sign of your enthalpy change. Okay, so same thing, before water can be broken down, before water can form hydrogen and oxygen, the bonds in water have to be broken down. So the energy level will rise up before it comes down. Okay, so this is how an energy profile diagram for the opposite reaction looks like. Now, one very important thing to take note now is where is the activation energy? Where is the activation energy for the opposite reaction? Now, very importantly, you need to keep in mind that the activation energy is between your reactants and the highest point. So in this second reaction that we're looking at, the reactants would be your water. So your activation energy would be from here, your reactants, to the highest point. Okay, so this is the energy profile diagram for the opposite reaction. So a few things to take note here. Remember, in an energy profile diagram, same as energy level diagram, the arrows only go in one direction. Okay, do not draw a double-headed arrow, and the direction of the arrow must indicate whether it's an endo or exo. So if it's an endothermic reaction, the energy level of your product is higher than your reactants, the arrow must be pointing up. If it's an exothermic reaction, where the energy of your products is lower than your reactants, then the arrow must be pointing down. The last thing is this, sometimes in O levels or even A levels, they will ask you to draw an energy level diagram. Okay, so the question will ask you to draw an energy level diagram. However, in the question, they give you the axis, they give you an x-axis for you to draw. Okay, so in O levels, if ever they give you an x-axis, despite them saying that it's an energy level diagram in the question, they actually want you to draw an energy profile diagram. Okay, so again, if the question gives you an x-axis, so they give you the axis to draw on, and the x-axis is given, even if the question states that they want an energy level diagram, essentially they are asking for an energy profile diagram, because energy level diagrams have no x-axis.